Hi, so I'm going to show you an example how we can use our calculator when we have an example that gets to be a little bit more work using a z-score table. So of course you can use the z-score table for this, but I want to go ahead and show you how to use this on the TI Nspire. So the question asks what percent of the elephant pregnancies last between 600 and 615 days. So we still have our normal model with a mean of 609 and 31. So I have the x-axis labeled, I have the z-scores labeled, and I'm going to go ahead and sketch where approximately the score of 600 and 615 would be. So it would be somewhere here and here. So it doesn't need to be exactly. It just shows you that is definitely 600 is under 609 and 615 is under 640. So it's somewhere between here. Okay? So this represents a score of 600 approximately here and 615. So I'm going to go ahead and use the calculator and show you how we can find the area between two values. Because if you were to use a z-score table, you would need to find the z-score here and then the z-score here, and then you would need to subtract the areas, which of course you should know how to do, but I want to show you how to use the calculator. So using the calculator, we're going to go to statistics. Under distributions, we have something called norm CDF. And so I'll show you what that looks like. All right, so using our calculator, I'm going to go to menu and go to statistics. And under statistics, we're going to go to distributions. Under distributions, we're always going to look at either number 2 or 3 for the normal model. So never use number 1, which is norm PDF. We're going to use norm CDF. So the C stands for cumulative. So when you click that, norm CDF, you will see the lower bound. So depending if you have the yellow calculator or the black one will show you the yellow one will show you -9 to the exponent 999, and the darker ones will show you negative infinity. But irregardless, this is a lower bound, and our lower bound value in this case is 600. So you want to put 600 in this case. Our upper bound is 615. So always put your lower bound first and upper bound. Now look at our mean. Our mean is set to 0 and our standard deviation is set to 1. Actually, what we're going to get is the area if we use the z-scores. But let's go ahead and put the mean here. So we're going to change the 0. And we're going to put the mean as 609. And the standard deviation is 31. So I'm going to go ahead and use a standard deviation of 31. So let's click OK. And so this actually just gave us the area between 600 and 615. So let me show you how we would write that down on a piece of paper. Okay, so using the norm CDF, I have it labeled the lower bound, upper bound, the mean, and standard deviation. So basically, our lower bound is, as I mentioned, 600. Our upper bound is 615. Our mean is 609. Our standard deviation is 31. And that gave us an area of 0.19095. So that's basically it. We already found the area using our here's the notation we would use. What's the probability of, in other words, the area under the curve where we have our values between 600 and 615. For all values between 600 and 615, I have it shaded over here, and that area corresponds to 19.09%. So this is basically 19.095%. So this area right here is 19.09%. So that makes sense because we know that between 578 and 640 is about 68%. So this is the area that corresponds to those two values. So we would say 95% of pregnancies last between 600 and 615 days.